Hello friends, today we are going to discuss communication channel from the subject Foundations of Communication and Computer Network. So what is meant by communication channel? It is the medium used to transfer the information from source to destination. It is the path used for transmission of electronic signals from one place to other. Different types of communication channels are there. First is continuous channel and next is discrete channel. So let's see continuous channel. It is analog in nature, analog input and analog output, which is described by the equation R of t is equal to bit of S of t plus N of t, where N of t is nothing but channel noise, beta is one constant, S of t is sender at the time t, and R of t is the receiver at another time t. Next is the discrete channel. It is also known as the discrete memory-less channel. When current output symbol is depend only on current input symbols and not on the previous one, then that channel is called as memory-less. That is, current output is depend on current input, not on the history. The channel is said to be discrete when message X and Y have finite size, has discrete input and discrete output. Current value of Y depend on the current value of X. It is in statistical in nature with the model X tends to Y. That is the noisy version of X. Here in this diagram, you can see here discrete input and discrete output. The input which is given as set of X messages with probability P, and at the receiver side set of messages Y with probability Q. So input X1 gives output Y1 with probability Y1 upon X1, because input and output are discrete one. In the same way, X2 gives output Y2 having probability Y2 upon X2 and so on. The same thing can be used by symmetric channel also, where set of input X consists of 0 and 1 and set of Y consists of 0 and 1, that is in binary form. Two sets are given here for input as well as output. Probability of error, that is receiving wrong bit, can be considered as P. Therefore, 1 minus P is nothing but the probability to receive correct bit. The channel noise and other disturbances cause statistically independent errors in transmitted binary sequence. Here in this diagram we can see the P is the probability of receiving a wrong bit, where N1 minus P is used to receive the correct bit as 0 passed 0 received, 1 passed 1 received, and when 0 is passed 1 is received, that is the wrong bit receiving probability is P, and in other case 1 is sent and 0 is received with having probability P, that is the probability of error while receiving wrong bit. The next, here we consider data rate limits. It is very important in data communication. How fast we can send data in bits per second over different channels. Data rate generally depends on three factors. First is available bandwidth, level of the signals, and next is the quality of the signal, that is the level of the noise in the signal. We see here Shannon and Nyquist rate for noiseless channel, it is also known as Nyquist bit rate, which is given by using formula bit rate is equal to 2 into bandwidth into log to L, where L is the number of signal levels used to represent the data. Bit rate is same as frequency representation in analog signal, that is number of bits sent in 1 second can be identified as bit rate. Theoretically, to increase bit rate, we can increase the number of signal levels, but practically it is not. By increasing the number of signal levels, its reliability of the system gets reduces. Let's see here. In first example, two digital signals are represented, one with two signal levels, and in another example, that is in another diagram, four signal levels are represented. In first diagram, digital signal with two levels, and in another diagram, digital signal having four levels. As we have seen, practically by increasing levels, signal levels, which reduces the reliability of the system. In first case here we can see the message can be identified with two levels, that is 1 and 2. But in another case, the same data can be represented with 4 levels. So which is somewhat inconvenience for us to identify that data out of 4 levels. So practically the number of levels increases, it reduces the reliability of the system. Let's see an example. The digital signal has 8 levels. How many bits are needed to represent per level? To calculate the number of bits from the formula, number of bits per level can be identified as log to L, just we have seen above formula. So number of levels represented here 8. So our formula becomes log to 8 gives us 3. So each signal level is represented by 3 bits. Next, one more example. Consider a noiseless channel with a bandwidth 3000 Hz transmitting a signal with two signal levels. The maximum bit rate we have to calculate here by using the formula. Bit rate is equal to 2 into bandwidth into log 2 of L. So same thing can be represented here by using same formula. Bit rate is equal to 2 into bandwidth is 3000 log 2 of L, that is number of levels, two signal levels. It gives 6000 bits per second. Take one more example. Consider the same channel with transmitting signal, 4 signal levels. For each level we need to send 2 bits. The maximum bit rate can be calculated as, just we can replace here the value 4 instead of value 2 as number of levels. Therefore we will get here bit rate is equal to 12,000 bits per second. Take one more example. We need to send 265 kilobits per second for a noiseless channel with a bandwidth of 20 kHz. How many signal levels do we need? According to this Nyquist formula, we can write here bit rate is equal to 2 into bandwidth into log 2 of L. Substitute all values, then we can get here L is equal to 98.7. Since the result is not the power of 2, we need to either increase the number of levels or reduce the bit rate. If we have 128 levels, then bit rate is 280 kbps, and if we have 64 levels, then bit rate is 240 kbps. Next, we can see here for noisy channel, because noiseless channel is not exist in reality. Therefore, we consider here another channel as noisy channel. It is also known as Shannon capacity, which identifies the characteristics of the channel. which gives the formula capacity is equal to bandwidth into log 2 into 1 plus SNR. SNR is nothing but signal to noise ratio. Bandwidth is the bandwidth of the channel and capacity of the channel in bits per second. Data rate can achieve up to the capacity of the channel, not above than that. So here, consider example. Consider an extremely noisy channel in which the value of signal to noise ratio is almost 0. Therefore, we have kept here signal to noise ratio as 0. SNR is 0. In other words, the noise is so strong that the signal is faint. So, the channel capacity is calculated as 0 because according to the Shannon capacity or formula C is equal to 3 to log 2 plus 1 plus SNR. We have taken here SNR value is almost 0. Therefore, log 2 gets 0. This means the capacity of the channel is 0 regardless of the bandwidth. In other words, you can receive any data through this channel. We'll take here one more example. We have a channel with 1 MHz bandwidth and the signal to noise ratio for this channel is 650. What are the appropriate bit rate and signal level? First, we use Shannon formula to find out the upper limit of the channel. C is equal to B into log 2 plus 1 plus SNR. By using it, we can get the capacity of the channel is 6 Mbps. The signal to noise ratio is often given in decibels. Assume signal to noise ratio in decibel is 36 and the channel bandwidth is 2 MHz. The theoretical channel capacity can be calculated by using the same formula which is noted here and we'll get result C is equal to 24 Mbps. The number of examples you can note here. Practically, we need both methods to find the capacity of the signal levels. Let's take an example. We have channel with 1 MHz bandwidth and SNR for this channel is 62. What are the appropriate bit rate and signal level? The same thing. Just we have noted here. First, we have to use Shannon formula to find out upper limit. And next, the Shannon formula gives us 6 Mbps, the upper limit. For better performance, we choose something lower, that is 4 Mbps. For example, we use the Nyquist formula to find out number of signal levels. By using the Nyquist formula, we can calculate here level is equal to 4. The next one is the Shannon-Hartley theorem, which also identifies as information capacity theorem. The information capacity of a continuous channel having bandwidth B Hz is disturbed by additive void Gaussian noise of a power spectral density N0 by 2 and limited bandwidth B is given by using this formula C is equal to B into log 2 plus 1 plus S divided by N0 into B, where channel capacity is C depend on channel bandwidth. S is equal to average transmitted signal power. N0 by 2 is the power spectral density for additive void Gaussian noise at increase channel capacity by increasing bandwidth of the channel. Trade-off between bandwidth and SNR. As we know, C is equal to B into log 2 plus 1 plus log 2 1 plus S by N, that is signal to noise ratio, will effect on the capacity of the channel. The values of SNR and SNR dB for noiseless channels are infinity. We can never achieve this ratio in real life. It is an ideal. So channel capacity is infinity. So finally, easy to increase information capacity of the communication channel by increasing the bandwidth instead of increasing the transmitted power. So in this way, we have discussed some communication channels in the same point. Okay. Thank you.